In this video, we're going to talk about solving word problems. So I want to kind of outline a strategy by a famous mathematician, and then we're going to just solve several word problems, kind of working ourselves up in difficulty until we get to mixture problems at the very end. All of these word problems are going to be solved with one variable today because we are kind of using the solving strategies that we discussed in the last video on how to solve equations with one variable. All right, so George Polya is a very famous mathematician, and he outlined these steps for solving a word problem. Now, they look really basic and not profound, but he does have a book that he's written, a really short book on this topic, and it does kind of go into detail about, how to get the creative juices flowing to solve a word problem. So first we're going to read the problem, and that sounds really obvious, but we want to read it critically, right? Look for keywords and kind of really understand the scenario, if there's a scenario. Next, we want to try and take the information in the problem and write an equation. Sometimes drawing a picture will help us get to the equation, sometimes making a table, and I'm going to show you some of those things today. Then obviously we're going to solve the equation. That's the part that we practiced in the last video that we're going to apply here. And then it's always good to do a quick check, especially if this is like a real world problem. Does your answer make sense? Does it fit in the context of the problem? Okay, so we're going to start really just with practice in identifying some of the keywords that may come up in a word problem. Excuse me. So maybe you see some keywords here that jump out at you. There is a whole list of keywords in your book in this section that you can go look for if you like. I'm going to point some of them out to you since we're not together in the same room today. So less than, maybe that's a keyword that implies some subtraction somewhere. The sum, that implies addition, right? Is a really good one that you're going to see a lot, and that implies equals. You could maybe argue that twice was a keyword, right? So we know that's twice means sort of like a double. All right, so maybe that's enough to get us started. This one is kind of tricky, so you have to watch out for the less than one because it doesn't translate directly in the same order that we see it in the problem. So I'm actually gonna save this for last, okay, or next to last maybe. So let's start here. Twice the sum of a number and 5. So let's use, pick a variable. I'm going to be boring and choose x. Okay. So if it's twice, that means 2 times. Right? So I'm going to put it in parentheses. The sum, which means I'm going to add a number, which I'm using x to represent, and 5. So this would be the translation of this little piece, right? Twice the sum of a number and 5. Okay, and now let's add in the 7 less than all this, right? So what that means is I have all this and I want to make it less by 7. So normally if we subtract, we would subtract in the back, right? And so it doesn't follow numerical, right? It doesn't follow in order like we have it in the words, but less than always goes in the back. And then the last part we'll add is the equals, right? So is 15. I will say that for most of the word problems, the hardest part is just coming up with the equation. The solving, usually you guys have that down by now. Okay, so but let's go ahead and finish this one out. We talked about distributing first. Then we'll combine like terms. Then we want to get our variable by itself, so we'll subtract 3 from both sides. And then since we're multiplying by 2 here, to get rid of the 2, we'll divide both sides by 2. And since we're just talking about a number, the context doesn't really make a difference. If we wanted to check our answer, we could always go back and plug it in here and do a quick check. I'll leave that for you to do, but it would be wise on a test or something like that if you wanted to make sure it worked. Okay, so those are some keywords. This is another example that kind of uses a different kind of keywords to help us set up a word problem. So this one, also from your book, says the sum of 3 consecutive integers is 135. Find the integers. Okay, so if we wanted to pick out some keywords here, here's the word sum again, so I know I'm going to take these 3 numbers, I'm going to add them up. Okay, so we might need to kind of define some things. So what does it mean to be an integer? This would be a positive or negative whole number. So no fractions, no decimals, either say a positive 5 or a negative 5, right? Some kind of numbers like that. Okay, what about consecutive? So what does consecutive mean? This means that we were looking for 3 numbers in order. Consecutive means in order. So all in a row, like 1, 2, 3, or 4, 5, 6, or something similar to that. All right, so that's all of those pieces are really crucial here. We don't really have a whole lot to go on. Okay, but we know we have 3 numbers. We know that they're not fractions, and we know that they go in order. So we need a way to represent them. So although it's really tempting to say, okay, x, y, z, right? Remember at the beginning we said we're just going to use one variable in this video. So let's use our variable to represent the first integer. Again, I'll be boring and choose x, but any letter you like will work. If the first number is x, how can we represent the second number? We're going to use the fact that they're in order. So if it were, say, 4, 5, 6, right? If 4 is the first number, then to get the next number in line, I would have to add 1, right? To get from 4 to 5, say. And it didn't have to be 4, 5, and 6, but any numbers, whatever numbers I get is my solution. They're going to be in order. And then the same thing for the third number, I'm going to add 1 more. So x plus 1 plus 1, or x plus 2. Okay, and so this is kind of an important idea that we would use the relationship between the numbers to come up with a way to represent them, even though we're still just using one variable. I think now that we've set this up, I think we're ready to make it into an equation, because we're just going to take the sum. Oh, I missed this one. And the sum is equal to 135, right? So let's do that. So we'll have x plus 1 plus x plus 2 equals 135. Now I always like to put the parentheses on just so you can see the 3 separate numbers. All right, but we can definitely just take the parentheses off, because now we want to solve, and we'd really like to combine all of the x's together. There's 3 of them. 1 plus 2 is another 3. Okay, and now we're solving, so we're going to subtract 3. And we're going to divide by 3. Okay, we might have to think a little harder about this or pull out our calculator. 3 goes into 13 4 times, right? Bring down the 1. Okay, 44, I think. Keep in mind, remember, we're asked for the 3 numbers. This is one of them, the first one, right? So to get the next one, we'll add 1, and then we'll add 1 again. So here's our 3 integers, right? 44, 45, and 46. Okay, so I hope that kind of gave you a little bit more. We're trying to open the window a little wider each time to give you more of an idea of how to take the words and form them into an equation. All right, here's the next question or word problem. It says the length of a rectangular room is 2 feet more than its width. If the perimeter of the room is 80 feet, find the length and width of the room. Okay, so now we're kind of, like we said, moving up in difficulty. Maybe, at least to start out with, maybe we want to use L for the length. We are going to be working with just one variable, but it's really common for us to use L and W, so I want to go ahead and pencil that in anyway. I like to draw a picture for this particular type of question. It is a rectangular room, which means I could use a rectangle to represent it. I have 2 relationships here, one in each sentence. So one in the first sentence and one in the second sentence. You can do this problem a couple different ways. I like to label my picture and then talk about what perimeter is, but I'll also show you the formula for the perimeter if you would rather do it that way. Okay, so I like to take, for this problem, the first sentence and directly translate it into symbols. So I have the length, that's L, of my rectangular room, is, there's my equals, 2 feet more than the width. So 2 feet more than the width. Okay, and I put it in the same order as the sentence, but you could also have W plus 2 here. Right? Either one is fine. Okay, so in terms of our picture, right, the longer side is the length, the shorter side is the width. So the 2 sides are my widths. Instead of using L to represent the long sides, I'm going to use this 2 plus W or W plus 2. Okay, so I've used that first sentence to kind of get myself to the point where I can just use one variable, which remember we said we were going to do. All right, the idea of perimeter is kind of like a fence where we add up the lengths of all the sides. So let's do that. We can just do that based on what we've drawn here. So we have the width plus 2 plus W plus the width again, plus 2 plus W, and that should be equal to the perimeter, which we're told is 80 feet. So this is our equation. Now we just want to solve. 1, 2, 3, 4 W's, and 2 plus 2 is 4. So we'll finish solving for the width. We'll subtract 4. That's going to give us 76, and then we're going to divide by 4. And again, you could pull out your calculator. I'm going to try to do it in my head because I didn't bring my calculator over here. 4 goes into 7, 1 time, 36, divided by 4 is 9. So 19 feet for the width. And we really are asked for both the length and the width. So remember the length is 2 plus W. So 2 plus 19 means the length must be 21 feet. Okay, if you are a formula person and you'd rather use the formula than the picture, let me outline what that would look like. So this is really more of a two variable approach, but I'll go ahead and show you anyway. All right, for a rectangle, the perimeter is 2 lengths plus 2 widths. Okay, and so what happens when you use two variables is you can make a substitution and use that relationship in place of L. So you already know the perimeter is 80. And in place of the length, we can put in the 2 plus W. Okay, it's still the same thing. It's just we added them up separately, and this formula is a little bit more condensed. But we're definitely going to get the same answer. We're going to combine these. I'm going to subtract 4. I'm going to do that at the same time. And then we're going to divide. And we're definitely going to get the same 19 feet that we got with this method. Okay, so either of these methods are fine. Whichever you feel more comfortable with works both ways. All right. So this was a rectangular room, which is something in real life. It could be a soccer field, right? This problem comes up quite a bit. Okay, now we're going to start stepping into some of the mixture problems. So we're going to use some of the same strategies we just used on the rectangle in these couple of scenarios that we've got here. So here's the next one. It says Carlton deposits $10,000 into 2 accounts with interest rates 5% and 8%. So in maybe the first account, right, he's deposited some money at 5%, and the second account, he's going to earn 8%, right? And I usually get the question, like, why would you do 5% if you could put all your money at 8%, right? Usually the higher percentage is a little bit riskier, so maybe it's a stock that fluctuates up and down more than the 5%, okay? All right, and then it says, if his total annual interest is $725, find the amount deposited at each rate. So if he did this, right, he invested his money for 1 year. Annual here means in 1 year, this is how much interest he earned. And so using that clue, we want to know how he divided up his money. So he has taken the $10,000 and he's broken it up into 2 groups. We're going to assume that he invests all of it. Okay, and what we're trying to find out is how did he divide it up? Is it 1,000 and 9,000? Was it 2,000 and 8,000? Was it 5 and 5? Right, we're trying to figure that out. Okay, so let's say, just as an example, let's say he did do 3,000 at 5%. Right, that's just an example. Then how could we find out how much he deposited at 8%? Well, we could take the total, right, minus the 3,000 would give us how much was left, right? That's kind of the idea that we want to use to set up our variables. So we know in total he has $10,000, but because he's breaking it up and we're not sure how, we're going to use, remember we're just using one variable. So we're going to use our one variable for the amount of money he deposited at 5%. So that's sort of representing this. I put 3,000, but that was just an example. We don't know how much. Okay, then we're going to use this same process to find, right, I call it the rest. So how much was left from the 10,000, and that must be how much he deposited at 8%, right? So that would be kind of think of this 3,000 as x. So we're going to take the total 10,000 minus x. And that's going to allow us to represent the rest of the money, right? So you're going to see this come up a lot where we have use one quantity or amount as x or whatever variable, and the second one is going to be the total minus x. So you might want to hang on to that idea. Okay, so we've set up our variables. That kind of allowed us to use this 10,000 number, right? Next, we need to incorporate the interest so that we can add it up and use this criteria to make our equation. You can use a chart for these if you like. I've found over the years that some people love the chart because it's organized. Some people hate the chart because it's just too much work. Okay, so it's totally up to you. If you can go straight from where we are now to the equation, by all means, do that, okay? But if you need to kind of have a way to organize the information so that you understand where it's all going, maybe a chart would be a good tool for you. Okay, so the formula we're using to make the equation is basically what the calculation you would use to calculate your interest, right? So you would take the rate or the percentage, we're going to write it as a decimal, times the amount of money you're putting into that investment, that's usually called the principal, and then you're going to get the interest. This is really just like calculating a tip, right? You take that 20% of however much you bought, and then that's your tip. It's the same type of calculation. Okay, so we have money deposited at 5%. If we write that as a decimal, that's going to be 0.05, right? The percent sign means divide by 100, so we're going to move the decimal 2 places to the left. That's where I got that. X is the amount we're investing, okay, and then in a minute we're going to multiply that across. For the second account, we have 8%, and we're representing how much is invested by 10,000 minus X. Okay, so if I multiply across, the interest I get from the first account is 0.05x. From the second account, it's 0.08 times 10,000 minus X. And then I want to add these up. I'm told in the problem, let me see if I can get it all on the screen at the same time, that the total annual interest was this $725. So these two are going to add up to be $725 of interest. Okay, so that's our equation. Let's write that down. So it's be in this last column if you use this chart. So it looks like this. We're going to give you lots of opportunities to practice these, and I like to give you ones that are very similar in setup. So maybe the context is different, maybe it's not, maybe it's an interest problem just like this one. I try to be pretty consistent so that you can recognize what to do, but otherwise all these mixture problems are going to kind of be this set up the same way. Hardest part is getting the equation, so you want to take some time to practice that. The solving part, usually you've got that part down, but let's go ahead and solve this. So we're going to distribute our 0.08, and that's going to give us 800 minus 0.08x. We want to combine our x's together. And I'm going to do 2 steps at once. We're also going to subtract this 800 over to the other side. Okay, so 0.05x minus 0.08x would be negative 0.03x. And on the right hand side, I'm going to have negative 75. So when I divide, divide by 0.03, that's going to give me 2,500. And if I go all the way back to the top, remember X was the amount that I deposited at 5% interest. And then I could subtract, right, 10,000 minus X. So 10,000 minus 2,500 is going to give me 7,500. And that must be how much was deposited at 8%. All right, so definitely we're going to do a couple more, but you'll want to seek out some problems just like this so that you can try them on your own, right? See if you can follow this outline. Maybe use the video at first and then try to see if you can do it without the video and test yourself. So a couple more scenarios that are going to be set up a lot like that one. So let's do another one. This one's also from your book. It says, at first, an athlete jogs at 6 miles an hour and then jogs at 5 miles an hour, traveling 7 miles in 1.3 hours. How long did the athlete jog at each speed? Okay, so there is somewhat of a keyword here, right? How long? That indicates that we are looking for the time. Right? How much time did it take at each speed? So maybe you can picture this, right? This person is jogging. I hate running, so they're jogging, right? And then, you know, after some time, they get tired and they slow down, right? From 6 miles an hour down to 5 miles an hour. Okay, so yeah, maybe you can picture that, right? So let's see. We need to represent both how much time was jogged at 6 miles an hour and how much time was jogged at 5 miles an hour. We're going to use one as our variable. This time I'm going to use t since we're talking about time. Okay, so t will represent the time jogged at 6 miles an hour. We're using that same idea where we're taking the total time, which is this 1.3 hours, and we're breaking it up into 2 parts. Okay, so the same thing's true, right? We could pick a number for this part. How would we find the second one? Yeah, we're going to do the total minus x. We're going to take the 1.3 and subtract off however much we ran for the first part of the journey. So if I ran for 0.5 hours, right, then I would subtract to find out how much for the rest of the journey. This hopefully looks just like what we did in the last problem. I'm kind of using this idea again. Okay, so this time the scenario is a little different. So the way we make our equation is a little different because it's a different relationship. So this time we have rates and times and distances. So we're going to use that rate times the time equals the distance. Sometimes this is thought of as the dirt. If you put the D on this side, this is the dirt formula. Okay. All right, and you can use a chart if you like, or you can jump straight to the equation like we said earlier. All right. I'm going to show you the chart just so that you have that in case you like it. So the first speed was the 6 miles an hour. We ran for t hours. The second speed was 5 miles an hour. And we're going to represent the time by 1.3 minus t. And then just like before, we're going to multiply across. So this is the distance from the first part. This is the distance from the second part. And we're given the total distance. That's the only number we haven't used yet, which is this 7 miles. So these two amounts, parts of the journey, should add up to 7 miles. And that's where our equation is going to come from. Okay, this one looks a little less scary because our rates are whole numbers instead of percentages. But other than that, the setup is the same. So let's finish this one out by solving. So we'll distribute. 5 times 1.3 is 6.5. Okay, so we'll get our t's together. Maybe at the same time, we'll subtract 6.5. 6t minus 5t is just t. So it looks like t is 0.5. So remember, that's the time jogged at, so that's maybe we should say that's 0.5 hours jogged at 6 miles an hour. And then the second part of the journey, we're going to take the 1.3 minus 0.5, which would give us 0.8, so 0.8 of an hour. We're jogged at 5 miles an hour. Now, if you really wanted to get an understanding of this, you could convert that into minutes. Okay, I'm not going to require that, and I'm not going to do that right now because I don't want to cloud up what we've just done, but you could, right? We know half an hour is 30 minutes, right? So we could figure all that out if we wanted to. Okay, one more. The last one is a chemistry problem. So the setup for these sometimes can be a little bit different, but a lot of those same ideas are going to be used. The only difference here is this time we have 3 rates. So in this case, it's 3 percentages. And so we're going to have the 2 rates on one side of the equation and then the third one on the other side, which is something that we haven't seen yet. Okay, so let me read this one to you. It says, a chemist mixes 33 liters of 30% sulfuric acid with a sample of 80% sulfuric acid to obtain a sample of 60% sulfuric acid. How much of the 80% sulfuric acid was used? Okay, so maybe you can picture yourself in a chemistry class. You're trying to make an acid that is 60%, right? That's like your goal. Okay, so you've got 30 and you've got 80, and you want to add them together in the correct amounts so that you can get 60%, right? That's sort of the strength. Okay, this time we're only looking for one quantity or one amount. So we're going to use our variable. I'm going to go back to x for this one to represent that. The relationship that we're using is pretty important. So we're going to take the strength, multiply it by the amount of mixture, and that's going to give us the amount of pure acid. There's lots of ways to draw these out. The table is one way. Also, sometimes people like to draw these little beakers, so I'll do that down below. Maybe you don't need any kind of aid. Maybe you can just jump straight to it. That's totally fine also, right? Okay, so if we look back at the problem, we are starting with 30% acid. So why don't we go ahead and write that as a decimal? So 2 places over would be 0.30, right? And the amount of 30% sulfuric acid, remember we're starting with 3 liters. And just like in the other problems, we're going to multiply this across in just a second. Then we're going to add to that some 80% sulfuric acid. So we'll convert that to a decimal. We don't know how much we're adding, right? So we've got x there. Okay, let me copy that down here. So think of this, if this is all liquid, right? Some of it's water and some of it's acid. 30% of it, oh, my pin's dying. 30% of it is acid. And we have 3 liters. Okay, over here, 80% of it is acid, so a lot more acid to water sort of ratio. And we don't know how much, X liters. Okay, we would like to get an acid mixture that is 60%. So if you do use the chart, this time we need 3 rows, 1 for each strength, and the result needs to be in the bottom so that it's on the correct side of your equation when you set it up. So our goal here is to get a 60% strength of acid. Okay, and it doesn't tell us how much we're going to get, but we can easily reason that out. So picture these 2 beakers, right? One of them has 3 liters and one of them has X liters. If I pour them together into one big beaker, right? These are fluids, right? Or liquids. So 3 liters and however many liters this is, I'm just going to add them up liquid-wise, right? If I were just to pour 2 things together into one big beaker. So 3 plus X or X plus 3 is going to be the physical amount of liquid that I have. Now I'm going to use the amount of acid to kind of make this equal so I can get the right amount. So I'm going to multiply these across. So 0.30 times 3, 0.80 times X, and 0.60 times 3 plus X. So the 2 separate mixtures I'm adding together should be equal to the result. And that is going to be my equation. Okay, so I know this one is a little bit different, this part in particular, but I'm hoping that you can see how this is very similar to the ones we just did. These are also the type of problem that I would recommend taking some time to practice. Go find more of these, okay, and search them out so that you can test yourself, right, and you can kind of feel confident that you know what to do. Okay, so I'm going to distribute and multiply some things. I'm going to get all my x's together and all my numbers together. So if I subtract 0.60x, and I subtract 0.90, I always like to keep all of the zeros because it looks a lot like what I was working with in my percentage, but you could definitely drop the zeros if you prefer. Okay, so really this amounts to 9 divided by 2. If I take off the zeros and I multiply top and bottom by 10, that would be 9 over 2. So I get 4.5, and this was measured in liters. And if I go back to the top, remember X was representing the amount of 80% acid. All right, well, I hope this helps you get an idea for how a word problem works. I'm so glad you get to have a video so you can watch it back if you need to. Please do take some time to practice these and always send me any questions you have. All right, good luck out there. We'll see you in the next video.